guess.
And it's going. All right, you're good.
Okay. Okay, if you guys were here last time, I talked about how to create your own backdoor and have a reverse connection and your like communication channel between your backdoor and your server. Today we are kind of talking about a different topic here. So let me ask you first off, how many of you guys like did like raw socketing before in like Wi-Fi or no one? Okay, well, let's first check out our outline here. We're discussing how to like create your own frame, forge it, and send like a deauthentication attack. But we're not using AirPlay, we're not using Escapee, we will be using our own frame to do that. It's kind of different because if you look at the internet, you'll see everyone using Escapee. It's a really powerful tool, makes everything easier. But I kind of took a different route here to create my own frame. So we'll begin with some terminologies. Well, if you guys, I don't know if you know these kind of terminologies or not, but well, we have first access point and SSID, BSSID. That's our main terms here. Channels. Well, so you know the access point, I have one here. Well, this could act as a router or also access point. So when you say, like, when we say access point is basically we're talking about router or some access points you don't do routing stuff, so, but there's still a router is access point. So SSID here is the actual name of your access point. If you have a Wi-Fi in your house, you call it whatever, like whatever the name you like, Go Trojans or something. That's the SSID or eSSID, and the BSSID is the actual MAC address of that access point. That's the main part here. We're going to be playing with it a lot. Also, we have a channel number. We're not going to tinker with this today because we're not dealing with beacons a lot. But the channel number here represents a range of like the radio frequency that your access point is transmitting on. And then we kind of talk about the 802.11. That's your WLAN protocol. So we already discussed the MAC, and we have like 3 types here of the frame: data frame, control frame, and management frame. The management frame is the one we will be focusing on here more. So a MAC layer consists of these kind of fields. It's like if you've ever seen IP packet or TCP segment or any of these networking stuff. This is a MAC layer. What we need to focus on here is, of course, we're not talking about everything, but address 1, 2, and 3. Address 1 is basically the MAC address of the destination. If I'm sending a frame to the access point, that's going to be the destination, means the MAC address of the access point. If I'm the sender, of course, if the access point itself is sending me a frame, then I am the destination MAC address. So address 2 also is MAC address of the BSSID itself. So this, we will see this a lot because they might change. The BSSID will, like, the address 2 will become address 1 become address 2 based on who is sending to whom. Address 3 is the MAC address of the source. The management frames, we have many types of management frames, like authentication frame, deauthentication, association request, disassociation, probe request, probe response. So this picture here is showing us like the steps of your phone connecting to an access point. First, send a probe request. If it's already saved on your phone, like if you're already connected to this access point before, then your phone will try to find this access point in range. once it finds it, your access point will send a probe response with the SSID name or network name. And then you starting sending an authentication request, and then it will reply back with authentication response, and then association request, and then association response. So sometimes you can use, if your phone is going like off range, like away from your access point, it will send this association to your access point. It's like you're telling your access point, I'm going off. I'm not nearby anymore. But your phone will be sending this association, not the authentication, because the deauthentication or the authentication process takes a little bit of time. So you don't want to do this every single time you're going away from the router. So that's why your phone will be sending this association and not the authentication. So if we want to kick your phone off the network, we need to send which one? We need to send the authentication because it takes more time. If I'm sending like this association, your phone might take like a few seconds and it will just connect back. Maybe 2 seconds or maybe even less. So we already discussed the exchange frames that happens between your phone and the access point. Let's look at the Wireshark here. In this picture, so this is a frame, like a beacon frame. A beacon is like if your access point is like yelling and sending those frames so everyone can check them and see, oh, I'm access point, my name is, or my ESSID is this, and my BSSID or my MAC address is this. If you're interested, you can connect to me. So this beacon is from Wireshark. If we notice here, this is our main focus if we want to build or write our own tool to like parse the frames in raw socketing. If we notice here, the first 35 bytes, they are for a radio tab header. So how can we tell if this frame is a beacon frame or association frame or all the other frames that we discussed? The byte number 36 here. This byte tells us something called subtype. Subtype, we can know from that what kind of frame is this. In this beacon frame, the subtype byte number 36 is actually 8 in hexadecimal. I'm not sure if you see this or not, but yeah, I kind of highlighted the first 35 bytes, and the very first byte, this one here, this is the subtype. So the subtype is this 36 byte. If we want to filter all the frames, since we are receiving every kind of frame, beacons, authentication, and deauthentication, all frames, but we want to filter just beacon frames. We want to look for byte number 36 and see if it's equal to 80 in hex or not. You can see if it's 80, the number 36, after the highlighted 35 bytes. And then we can take it from there. At least now we can filter only beacons frames. This is another picture showing you the exact, I'm highlighting number, byte number 36, it's 80. So how do we find ESSID? We're not using Escapee yet, we're just using raw frames. So first we need to find the subtype, byte number 36. If it's 80, then we take it from there and we continue. Now we need to know what's the length of the ESSID, the network name itself. To find that, usually it starts from byte number 73. So, 74. So from 73, this is the length of your ESSID or the name of your access point. So why do we need to know the length of the access point? Because we want to count how many bytes we will go further of this byte, 73. Like how many bytes after 73 is the ESSID name. So we get the byte number 73, we save it in a variable, let's call it len of SSID. And then our actual ESSID name will be starting from byte number 74. We're using a list here to 74 plus the links of the SSID. In this case, maybe your SSID is just 4 characters, so it'll be like 4 bytes. So it'll be 74:74 plus 4 if you're not using any variables. So here, this is a different example. SSID here called CGNM whatever, like -9EB8. So the length of the SSID is 9. So if you go back here, it'll be 74 plus 9. If you're using Escapee, and this is a very easy way to do this, you just use Python, you just import Escapee, and then you define your variable, like your interface, and then you just check if it's .11. Escapee has a lot of layers. One of those layers is called .11, handling the Wi-Fi frames. So we're checking first if FM, it's the argument that we are passing to the info function. If it has a layer called .11, that means it's a Wi-Fi frame. And then we check if fm.type equals 0. It's very easy. You don't have to deal with any hexadecimal or bytes. Just check if the type itself is 0 and the subtype is 8. Subtype is 8 means we're looking for beacon frames. And then print ESSID, whatever, fm.address2. You don't even need to look for address2 in bytes. You just do .address2 or address1 or address3. So how do we do this in raw socket? First, we import the socket. We sniff it, like we do create a variable called sniff to save our socket. But this time we're using the packet. Oh, sorry. We're using AF underscore packet and socket.sock underscore raw. And the last argument is 3. 3 means we want to receive all frames. We don't care, everything. And then we bind to our interface, wline0mon. Of course, you have to put it in monitor mode to do that. And then we have now our all frames stored in variable called fm. If we take the first element of the frame, the frame itself, first element 0 is our actual frames that we want to look at. So we discussed already that the byte number 36 is our subtype byte that we need to look for. Here I'm telling my code if byte number 36 is equal to hexadecimal of 80, do something with it. I know now it's a beacon frame. I can look for ESSID or any other stuff. I can get the length of the SSID like the other slides, and then get the actual SSID by putting the 74 plus the length, and then print it on the screen. Here, like I said, the number 3, it indicates that ETH underscore PO, like we're looking for every frame. Let's look at the deauthentication frames. So you can, if you want to use a filter in Wireshark to just look for deauthentication frames, you can do like this filter, wlan.fc.type underscore subtype equal 12. 12 is the number of the subtype. If you put like 8, you get beacons. And yep, this one, let me just try and have a Wireshark here. So here, if I put 10, like the filter in Wireshark, I'm looking for disassociate beacons. If I change this to 8, hit enter.
It still has your presentation.
Oh, well, let me put the other one. Interesting. Kind of frozen now. Okay.
If you exit, you're like hit escape.
Yeah, no, never mind. Yeah. So here's the Wireshark. If you put 8, we're getting all the beacon frames. If you change this to 10 or 12, this is the one we're going to be playing with. Takes a little bit of time. This is a de-authentication frame. This was sent from AirPlay tool and on Kali Linux. So if we look at the 802.11, here, this is the addresses that if we want to build our own de-authentication frame, we need to know how to put these addresses together. Here, the receiver address, and this is the destination address. Transmitter, see the highlighting at the bottom? So they're not, all of them, they're not at the actual raw bytes. If you look at receiver and destination, they're not changing because they're one, they're the same. Receiver and destination address, they're exactly the same. Transmitter comes after destination in order, and then source is exactly as a transmitter. It's exactly the same, they're not changing. So you just need to know your destination and your source. That's all you need. Sequence number, you don't have to put all that, like the fragment and sequence number. You can just put anything, doesn't matter. And then the last part, you can just, it's a reason code. It's like why your de-authentication from the network. You can just copy your bytes from here and put it there because it doesn't really matter. Okay, let's continue. So, all right, can we build a de-authentication frame? Yes, we can. You can do this very easily with Escapee. And if you want to do it yourself, you just need to put all the pieces together, all the bytes together. So if you remember address 1, address 2, and address 3 from this picture here, if you want to put all of them together, so the first thing you want to do is the radio tab header. So if you want to just go back to the Wireshark again. This is the radio tab header. This one, it's 13 bytes. So your radio tab is not really important. You can just copy and paste all the bytes, because if you look at it, just a length and just some information about your data rate and some flags. So you can just copy those old flags, it doesn't matter. But the actual important one here is this de-authentication flags here. It has all your important information like your receiver address, source address, and all that. So here we're putting our radio tab the first 12 bytes, and then at the end of the there is a frame control field and type and subtype here. Where's the type and subtype? We were talking about it here. Type and subtype. The type and subtype, they go together. It's like 00 and 0C in this de-authentication frame. So they go together. Don't look. If you look at here, it's only C0 in the byte itself. So if you want to build your frame, you just need to put your subtype as C0, the one is highlighted. Let me just, yeah, this one. And then we put the duration, normally 314 microseconds, so 3801. You can put it less than that if you want. And then receiver address, destination address, of course, in hex. So if you want to get that from your Wireshark, you can just copy, click here and copy, and then do escape string. And if you have like a Python or something, you can just equal see, you don't have yet, you can just copy and paste it like this. But if you want to be like make it more flexible, like you want to take your MAC address from input from the user, means you can just say if our MAC address is equal to AA BBCC. And then you can convert this to hex. Same thing. So let's go back to the slide. So again, receiver, destination, transmitter, sequence number, doesn't matter. You can put all zeros in the sequence number. As long as you're not sending, if you're the only sender, you can just leave it zeros. If you're sending one frame from you to your access point and you're forging another frame from access point to you, then you can just change the sequence number, make it 1 and then 2 and just increment it. Reusing code, you can just leave it 0, the same one. If you put all the pieces together, create a function that do all these frames. You can pass your MAC address as an argument. You can pass it to the function and the access point also MAC address. And then you build your frame. You put all the pieces together and then you return the function. You return your frame and then you send it. Put in a true statement, frame equal deauth. Deauth is the function that I was just showing you. And then you use your socket s.sendAll and then your frame. Let's look at that here in a second. Let me just connect to let's see if my Kali is still up. Well, it's not actually up. Let's give it an IP address. Okay. Let's put this here. So this is a tool that I wrote to do the same thing. This is my deauth, and of course, if you go back here a little bit, I'm using argv to get the MAC address of the access point and the client, and I convert that to hexadecimal the same way I showed you using that decode function. So if we pull up my phone here, see if it's still working. I have an access point here. I'm going to connect to it. It's called offsec. You can see that. Not sure you can. Okay. You just copy and paste my command from here. So now I'm giving my tool the MAC address of the access point and then the MAC address of my client, my phone in this case, and how many frames I want to send. I'm sending a deauthentication frames to disconnect my phone. Let's try. Well, sometimes it doesn't really disconnect from the first time. Oops, almost there. Yeah, let's send more 50 frames. See? Disconnected and connected to Go Trojans. Right? So in this tool, I have 2 frames. To make it more efficient, I'm sending a frame from my phone to my access point and another frame from my access point to my phone. Of course, they're not sending anything. I am forging all those frames and I'm sending one on behalf of my phone and another one on behalf of my access point. But of course, I have to change the address 1 and 2, 3 to match who is sending and who is receiving in order. All right, I think that was all. Peter, you got a question?
Yeah. Do you just use like Airmon to get your WLAN interface in a monitor mode, or was there another cool way to do that?
Yep, Airmon, yep.
Airmon, okay.
Yeah.
Any other questions for Terry before he has to head off to work?
Do you have it open sourced anywhere?
Yeah, I mean, I can, if anyone wants, I can just give it to them, yeah.
Okay, cool.
And also, forgot to say something that if you're forging disassociation frames, then you need to have a frame check sequence in your frame. And I'm gonna save you maybe days of looking and researching. So when I was forging a EAP frame, I actually had to go to find it in the Escapee source code itself because I wanted to know how they're generating the frame check sequence. And here, oh, I'm sorry. I think you're, let me just put it back. This is from Escapee's source code, this exact 2 lines. So they are calling a function called CRC32 from zlib library. So if you go all the way up and search for CRC here from zlib, import CRC32. If you import the function, then you can use the pack, like packing the frames and using to generate the frame check sequence. And in order to do that, your frame check sequence only works at the actual frame without the radio tab part. So do not create a frame check sequence on the entire frame. It won't work. It will give you a bad or invalid frame check sequence. So if you look at the Wireshark again, you do not do the frame check sequence on the radio tab, just the actual frame, this one. And let's look at the actual disassociation frame. Takes a second. Yeah, let's take a look at this one. Let's go all the way up. Yep, this one. This is the frame check sequence. It's the last 4 bytes in your frame. So if you want to use the function that I just showed you, you skip the radio tab header and then get all the other bytes except the last 4, and you pass that to a function and it will give you your CRC or your frame check sequence. And then you add those 4 bytes to the end of your frame, and now you have it. Any other questions? Okay, well.
I'll kind of quickly go over what we would normally have at the beginning of the meetings, but just due to time.
Yeah, sorry about that.
Oh, that's fine. That's all good. So questions.offsec.club was still a thing. I don't think anyone posted anything in there. I had it up. And if you haven't filled out attendance yet, just do that so we know you were here. Coming up tomorrow, it's ACM prep for programming club. So we'll be going over, I don't know if it'll be like previous ACM problems or like going over algorithms that are commonly used in ACM problems. So if that's your thing, then go to that. Computer club, there won't be computer club next Monday because there isn't school. It's Veterans Day. DefSec will be talking about SQL. They'll probably also have like a little bit on how to actually use SQL. So that should be good. And then I'm guessing it'll be more of like user management, that sort of stuff too. And OffSec next week, Logan will be talking about using pwn tools and actually making an exploit for a challenge that was on a wargaming site, pwnable.kr, or what site? Okay. So, on the 16th of November, This is like straight from the computer club email that went out. It's this technology fun day thing that Tom is running, and it's just meant to be like, come have fun. We're going to do weird stuff. There's something called a hexathlon because of hexagons. So it used to be like 8 challenges, and then they moved it to 6. But it's like do some programming stuff and other challenges. I think they've had part of the like hexathlon, or yeah, whatever that is, was like who can terminate an Ethernet cable the fastest. Like that was one of the legs of it. So it should just be fun time, pretty chill. And then on the 8th of December is another Major League Hacking event. So the last one was a Learn event, and this is Build, and it's hackathon in the sense of like hacking a project together. And then normally they do like judging and hand out prizes, I think, right? So that's a good time. Just get like a couple of people you want to work on something with, you present it. There's a long form mock that the attack phase is December 9th, but you will have access to machines before that. So this mock competition is more like Ice Age and Cyberforce, where you have access to the environment and the attackers don't. So you get to be in it for a couple of weeks and fix all sorts of stuff, and no, red team isn't like already messing with you. So it's a little less stressful as soon as, you know, red team is actually released. So yeah, you get to prep, and there's all sorts of backdoors, and you've got to like really dig some gross stuff out. You don't have to worry about like, oh, they're gonna kill my SSH session or whatever. And the sign up link is right there for anyone who wants to sign up for that. I don't know when that closes. So, and then this is the last thing I think we have, the Hack the Box CTF. That's, let's see, what day?
2 weeks from today.
Okay. So DSU can only have one team, and it's a bunch of universities competing with each other. We can have 5 people on a team. This disgusting sign-up link is what you need to do. I think it's in the CTF channel, probably also OffSec as well. You might just have to scroll up a little bit. I think it's a pinned post in CTF. And you need to be on the DSU Hack the Box team, and the top 5 people in the like DSU whatever team rankings that have said, yes, I want to participate in the CTF are the 5 people that are chosen to participate in the qualifier. And then I have no idea when the actual like finals or semifinals, whatever the heck they're doing, are. But Hack the Box normally has some pretty fun CTF problems, so should be a good time. Yeah, just go in there, do challenges, do machines if you're interested. All right, anything else that I missed at all? Q, you got anything? Just chilling in the back. I like it. All right, I think that's all we've got this week, so thanks everyone for coming. Oh.